Okay, so today we're going to split 5-3 into 2 days. Today we're going to go back to SOHCAHTOA. So for here, this is a screenshot from your textbook. We're going to be talking about right triangles today. More specifically, we'll be talking about the special right triangles, the 30, 60, 90, and the 45, 45, 90. Last year, if you took geometry here, we used those special right triangles quite often, especially when we got to the polygons and we drew in those apophthegms and we had to turn all of those polygons into special right triangles in order to find side lengths and radiuses and different things like that. So again, if you've memorized from yesterday that the side opposite is also y and the side adjacent is x, and then the hypotenuse was r, again, you can continue to associate those sides the same way. Now, remember, whenever we do this right triangle trig, we're always going to do it based off of an acute angle. So I'm going to be doing all of these based on either angle A or angle B. I wouldn't be doing it based off of the 90-degree angle. So let's try our first example. I've got a right triangle here, and I want to find the values for the 6 trig functions, and I'm going to either use SOHCAHTOA, or if you want to put in the y, the x, and the r, you can do that also. So remember for sine, if you remember from geometry, it was so opposite over hypotenuse. So for this one, opposite is 7, hypotenuse is 25. I'm going to flip it to reciprocal for the cosecant, and it's 7 over 25. For cosine, that is going to be the c, and that would be adjacent over hypotenuse. So for that one, we're going to put 24 over 25. For the secant, it's the reciprocal. And then for tangent, that would be the TOA, or opposite over adjacent. So 7 over 24. And then for cotangent, flip it to the reciprocal. Everybody remembering these? Doing it this way. All right. Now we're going to talk about the special right triangles. So the first one that we're going to talk about is the 30, 60, 90 special right triangle. What you need to be able to memorize and recreate is this right triangle. The side that's going to be opposite of the 30-degree angle is always going to have 1. The side opposite the 60-degree angle is going to have the square root of 3. The side opposite the 90 is going to be 2. Now, the way that I remember which special right triangle gets square root 3, which one gets square root 2, is I remember that the 30, 60, 90 has 3 different angles, so it gets the root 3. When you get to the 45, 45, 2 angles, it gets root 2. Now, once you've identified and put in the 1, 2, and the square root 3, now I'm going to fill in the trig functions. Now, they're always going to be based off the acute angle. So the first time I do this question, I'm going to be doing it for the 30-degree angle. So I'm going to go ahead and label my sides based on 30 first. So this side is opposite, this one's adjacent, and this one is the hypotenuse. Now, the hypotenuse is going to stay the same whether I'm talking about 30 or if I'm talking about 60. What will switch will be opposite and adjacent based on the angle. So for the sine of 30, I need to do opposite over adjacent, because that's my so. And then here I would fill in 1 over 2. The cosecant is the reciprocal, 2 over 1. For the cosine, that is going to be the c, or the adjacent over hypotenuse. So for here, I'm going to do root 3 over 2. When I go to find secant, I flip it to the reciprocal. So then this would become 2 over square root 3. Again, I can't leave a radical on the bottom. I need to rationalize. Multiply top and bottom by root 3. And then that would be the answer for this one. For tangent, that's the TOA. Opposite over adjacent. And again, I have to rationalize. Multiply top and bottom by root 3. So root 3 over 3 would be the answer for tangent of 30. Now, for cotangent, it's reciprocal. I can either try to work with this, but then I get a radical on the bottom. If I go back and just use my original and flip it, then it's root 3 over 1, and I get root 3 as my answer. Now I'm going to change the angle and find the 6 functions based on the 60-degree angle. So now I'm going to change this. Now that I'm talking about 60, now the root 3 is actually opposite. And then the 1 is the adjacent to 60. So just having done this, you're going to see how the values are just going to switch places. But we're going to go through and work them all out. So again, sine is the so. So opposite over hypotenuse. Now it's the red writing. So opposite would be square root 3 over hypotenuse, which is 2. Then I'm going to flip it to reciprocal. 2 over square root 3. And then I rationalize. I know I already did it right here, but I'll do it again. 2 square root 3 over 3. For cosine, that is going to be the so adjacent over hypotenuse. So for this one, it'll be 1 over 2. And for the secant, flip it, so it's 2. For the tangent, we're going to do opposite over adjacent. So square root 3 over 1. So this is just square root 3. And then when I flip it, 1 over root 3, I need to rationalize. Root 3 over 3. So this would be how we can find the 6 trig functions on my special right triangle when it's a 30, 60, 90. The next one I'm going to do now is the 45, 45, 90. Now notice both acute angles are the same measure. So I'm only going to do it for 45 degrees because they're both the same. So let's say I just say I'm going to do it based off this. Notice both opposite and adjacent, they're both 1. The hypotenuse would be the same, no matter which one I pick, same thing, opposite and adjacent. So again, for sine, I'm going to do so. And again, opposite over hypotenuse. And I'm going to need to rationalize here. 1 over root 2. Multiply top and bottom by root 2. So this will give me final answer root 2 over 2. If I just flip the original and not the rationalized one, then I end up with square root of 2 over 1, which is just square root 2. Remember, I just did opposite over hypotenuse. Now when I do the again, the adjacent and the opposite are the same number. So these trig functions are going to be exactly the same. Then for tangent, we're going to do TOA, opposite over adjacent, 1 over 1, which is 1. Reciprocal, 1 over 1, and it's 1. You should memorize tangent of 45 and cotangent of 45. It'll come in handy later on. Now, our goal for this, yes?
If the opposite and adjacent weren't the same number, would you choose one of the 45s to use, or could you use either one?
they need to be the same because it's an isosceles triangle. And when you have two angles the same, then the sides opposite, they're also going to be congruent. Does that make sense?
Yeah.
It's like the isosceles triangle theorem and the converse of it. So if you have two congruent angles, then the sides opposite them are congruent and vice versa. Okay, so they would always be the same in the 45, 45. Okay? Yes?
Where'd you get the radical secant of 45?
Okay, so what I did was I just saved time. I'll go ahead and actually work it out. So when I go to do these, I just copied what was above. But for cosine, it's adjacent over hypotenuse. And I had to rationalize that. So multiply it by root 2 over root 2. So then cosine is actually going to be square root 2 over 2. And then for the secant, if I just took what it was before I rationalized right here and flip it, it's root 2 over 1, which is just root 2. Notice these are the same things because, again, opposite and adjacent are the same numbers. Does that make sense? All right. So the whole purpose of this, of doing these special right triangles, is we're going to be able to find the 6 trig functions of really large angles. And what we're going to be doing is we're going to be finding the reference angles to those large angles. And we're going to learn what a reference angle is on the next slide. So a reference angle is going to be a positive angle. It's a positive acute angle. And it's going to really be the closest way for me to get back to the x-axis, or the quickest way. Don't get confused with the y-axis. We want to know the quickest way to get back to this line, the x-axis, not the y. So I'm going to go through each one of the quadrants and I'm going to draw in an angle, and then you're going to tell me what would be the quickest way for me to get back to the x-axis. So if I'm in quadrant 1 and I draw an acute angle, let's say it's 30 degrees. Now, would it be faster for me to just keep going and finish the angle to get over to this side? Or would it be faster for me to turn around and just go back down? Which would be the smaller angle? Going back down. Okay, so when it's in quadrant number 1, the reference angle is just going to be the same acute angle. So here the reference angle is 30 degrees. It's the same that I just measured. Now, when it's in quadrant 2, so let's say I draw an angle that's going to be 135 degrees. Again, I need to find out, is it faster for me to turn around and go backwards to the x-axis? Or would it be faster for me to keep walking and hit the x-axis this way? Which way would be a shorter distance? Keep going, right? So then I need to figure out how much this angle is. And the way that I do that is 180 minus 135. And then to finish that walk, it would be a 45-degree angle. So what you're doing is you will draw in one of these large angles, and then you would have to figure out how much more it would take to either keep walking and get to the x-axis or turn around and go back. So then now the next one I'm going to do is in quadrant 3. So again, if I start here at my initial side and I circle around 180, and let's say I go another 30 degrees, and now I'm at 210. Is it faster for me to turn around and go back 30 degrees or to keep going 150 degrees? Go back. So again, my reference angle for 210 is 30. So this one, the reference for the 135 is the 45. I'm going to draw one more in quadrant number 4. Let's say I draw a 330 degree angle. So go around, round, round, 180, and then 270, and then a little bit more, 330. So let's say I went 60 degrees more to complete that 330, and let's say that one's 30. Okay, so my reference angle here is going to be what I would have kept walking. So I could do 360 minus 330. So to finish it off, my reference angle here is the 30 degrees. Notice all of these reference angles that I drew in here. It's like a bow tie. These are all the reference angles. Notice they're all angles in a special right triangle. So what we're going to be doing is creating our angle and then creating a triangle based on the reference angle. So we're going to try some examples. We're going to do 9 of them. I'm going to give you time to do some of them on your own. So on this next slide that's blank, I just wanted to show you that when you have your angles, let me do a different color. Notice again, it makes like a bow tie, and all of the reference angles are going to be located in here. But notice what we're creating are right triangles here. So here you thought you were done with geometry. It's coming back. All right, so let's do the first example. We're going to go to this slide where I already have the sine of 210 written on it. All right, so the first thing I'm going to do is graph my 210 degree angle so you have a visual here. So I'm going to go ahead and I'm going to start here on my initial side, and then I'm going to circle around 180, and then I still need to go 30 degrees more, because if I know that 210 minus 180, that means I need to travel 30 degrees more to finish off that 210 degree angle. So I've made a 30 degree angle here. This is in standard position with the angle of theta, or in this case it's angle 30, at the origin. I'm now going to drop down my line here, and I'm going to make a right triangle. So my right angle is this perpendicular distance here. So again, now I'm going to fill in my 1, 2, 3. Remember, this side opposite 30 is 1. The side opposite 90 is 2. The side opposite 60 is going to be the root 3. Now, remember the signs in your quadrants when you graph order pairs. In quadrant 1, the signs are positive, positive. In quadrant 2, negative, positive. Quadrant 3, negative, negative. And 4, positive, negative. So I know that the signs, this is my X, this is my Y. They're both going to become negatives here in quadrant 3. Now, you can either just leave them all positive and then use the all students take calculus and know to put the appropriate sign on your fraction when you're done. Know that the only positive answers here in the third quadrant are going to be tangent and cotangent. So if you want to keep the 1, 2, 3 positive, just know that because we're trying to find sine, my answer I already know is going to be negative. But you can already put in the signs on your numbers as a way to double check. So in third quadrant, the X and the Y are negative, negative. So now I'm going to do the sine. So the sine of 210, what I'm using is the reference angle, so I'm really doing sine of 30. So I'm now going to do sine is opposite over hypotenuse. And my side that's opposite is negative 1, and my hypotenuse is positive 2. So the answer to this is negative 1/2. So either leave them as positive 1, 2, 3 when you do the sides, and then know that sine in the third quadrant is always negative. So that's the first one. Let's try another one. This time we're going to do tangent. Okay, so I know for tangent I'm doing opposite over adjacent, but the first thing I need to do is figure out which triangle I'm going to be drawing. So I'm going to draw my 30-degree angle. Now, if you don't want to draw it, notice that this 300 is going to be in the fourth quadrant. So I'm going to subtract 300 from 360. But let me draw the angle now. Initial side, 180, 270, and then another 30 degrees. So my reference angle is 60 now. So again, draw your triangle. Again, the side opposite 60 is the square root 3. The side opposite the 30, now the 30 is not at that origin. So then the side opposite 30 is 1, and the hypotenuse is 2. Again, in the fourth quadrant, the signs are positive, negative. So this one's positive, this one's negative. Side to side is the x-axis, up and down, leg is going to be the y. Okay, so now I'm going to do tangent. Tangent of 300 is equal to opposite over adjacent is equal to negative square root 3 over 1. And then I can just simplify it to negative root 3. I can get rid of the 1 in the denominator. Yes?
Why is it that the 2 is not negative?
Because the r is always positive. You would have done Pythagorean theorem to find it, and it's always positive. Now, again, you could have done all students take calculus. Again, the only two that are positive in the fourth quadrant are cosine and secant. We were doing tangent, so it's negative. Number 3, tangent of 675. So again, I need to get an angle that's in between 0 and 360. So what I'm going to do here is I'm going to start subtracting 360 to see how many times I need to circle around. So 675, if I start subtracting 360, I'm now at 315. I've actually got an angle that's in between 0 and 360. So if I were to draw this in, let me just draw it over here so my picture doesn't get so busy. So for 675, I'm going to go around to 360. I'm not at 675 yet. I'm going to go another 90, and then another, so another 180, and then I'm going to go a little bit more to 315. This would be where I would stop. So now to figure out how much more away from my reference angle, 315, subtract it, and it would be 45. So I'm going to draw in a 45, 45 here. That's my reference angle. The two legs are 1 and 1, and the hypotenuse is square root 2. And again, in the fourth quadrant, the signs are positive, negative, so I can do that. For tangent, we're going to do tan of 675. So it's going to be opposite over adjacent. Opposite is going to be negative 1, and adjacent is going to be 1. So answer is negative 1. Again, know where this is located. So again, all students take calculus. Tangent in the fourth quadrant is negative. I'm going to do another one, and then I'm going to let you guys try 5 through 9 on your own, and then I'm going to put them up so you can check. And then we're going to keep going. Okay, so number 4, cosine negative 240. So again, when it's a negative angle, I'm going clockwise. So if I go 180 and then 60 more, I've made my negative 240 angle. So here is my reference angle. It's faster for me to go back down than to keep going. Here's 30. Here's the right angle. Opposite 30 is 1. Opposite 60 is √3. And then opposite 90 is 2. Again, remember the signs in the second quadrant are going to be negative, positive. So -1 and positive √3. Now I'm going to do cosine. So cosine of negative 240 is going to give me adjacent over hypotenuse. And adjacent is going to be -1 and hypotenuse is going to be 2. Again, in this, all students take calculus. In quadrant 2, only sine and cosecant are positive. This is why I have a negative answer. All right, so what I want you to do now, I want you to work on 5, 6, 7, 5 through 9. And I'm going to give you like about 5 minutes or so, and then I'm going to start working them out. So I want you to do them right now, and maybe I'll ask some people for some answers. So everybody work on them by yourself. Give you a couple minutes here to do it. Recording this. The negative sign that's at the bottom, I can just put in front of the whole fraction. So I'm not going to multiply the top and the bottom by a negative radical. So this will become -2 times radical 3 over 3. Again, it's in the third quadrant. The only trig function that's positive, or the only two, are tangent and cotangent, because that's the all students take. For number 6, 135. Again, if I draw my angle here, go 90 and then go 45 degrees more. That's my 135. Again, the reference angle would be the fastest way to get to the x-axis, so this is the 45-degree angle. Again, the sides or the legs in the 45 are 1 and 1. Hypotenuse is 2. Again, the signs in quadrant 2 are going to be negative, positive. So this one's negative, the other one's positive. So for cotangent, that's the reciprocal of tangent. So cotangent of 135. Instead of adjacent, opposite over adjacent, it's going to be adjacent over opposite. So -1 over 1, and it's -1. For number 7, cosecant of 210. So again, I'm going to travel around 180, and then I'm going to need to go 30 degrees more to finish my 210. Again, my reference angle is to go back, and this is going to be 30 degrees because 210 minus 180 is 30. So for cosecant, it is the reciprocal to sine. So I'm going to do hypotenuse over opposite, and this will be, let me label these. Opposite 30 is 1, opposite 60 is √3, and then the hypotenuse. So here this is going to be 2 over -1. So final answer is -2. Again, the only thing in quadrant 3 is tangent and cotangent. For number 8, 510. Again, if I were to draw the angle, and I'm going to draw it over here to the side, and then I'm just going to put the reference angle on that. So again, I'm going clockwise. So for 510, if I start adding 360 so I get a positive answer, I would get -150 here, And then if I add another 360, I'm actually at 210. So I'm going to travel around 360, and now I need to go another 210. So I would go 90, keep going here. Actually go another 150, so I could actually draw it here. So 360, and then if I add another 90, and then 0, 5, 450, and then add another 60, then I get to the 510. So my reference angle is going to be here. So if I knew I went another 60 here, this leaves me 30 for my reference angle. Again, opposite 30 is 1, hypotenuse 2, opposite 60 is root 3. Signs in quadrant 3 are negative, negative. So again, sine of negative 510, going to be opposite over hypotenuse, negative 1 over 2. You could have also done sine of negative 150. All right, the last one that I'm going to do now, and then I'll finish up the notes tomorrow. I'm going to also go back and quickly do number 89 for you. I just wanted to get through these examples. So for negative 1020, I'm going to start adding 360 to figure out how many times I need to circle around. Or to get to my reference angle, that is going to be between 0 and 360. So subtract 660, or get negative 360, add 360, get 300, add another one, this is negative, add another 360, and now I'm at a positive 60. This is my reference angle. Now, if I were to show you how to do this, again, I'm going to go clockwise. So I would actually go around once, twice, once, that's 360, 270, and then I need to go again all the way around, another 90, another 180, until I get to here. And this would give me my negative 1020. So I went 3 circles. So notice how I subtracted 360. And then I went another 30 degrees, giving me my reference angle here of 60 degrees. That's what's left. So again, the sides opposite are a 1, opposite 30, opposite 60 is root 3, and opposite the 90 is 2. They're all positive. They're in the first quadrant. So again, tangent of this huge angle, a really small angle because it's negative, is going to be opposite over adjacent. Root 3 over 1 equals root 3. Now, don't automatically assume that because the angle was negative, you're going to get a negative answer. Again, in the first quadrant, every trig function is positive. So don't get misled thinking you have a negative angle, you should get a negative answer. Now, when it comes to the homework tonight, I'm going to move the due date to Monday. However, I'm going to do 4 more examples plus some more calculator problems tomorrow in class. However, for the homework, you can do these first 2. It's just the last 3 homework problems or concept that I need to teach you to do the last 3 problems. All right, so for those of you who do not need to see number 89, you can go ahead and start on your homework. I'm going to work out number 89 right now.